Okay. Our next example says 6 divided by x minus 1 minus 6 over x. Excuse me. This is 6 over x is greater than or equal to 1. Greater than or equal to 1. And again, same techniques. We bring our 1 to the left and we have 6 over x minus 1 minus 6 over x minus 1 over 1 is greater than or equal to 0. So I will be going a little bit faster for this problem. The last example prior to this one is extremely just like this. So if it's something that you don't catch as we go through this, refer back to the last example where we did a little bit more in detail. Again, our least common multiple, least common denominator, can be found by multiplying the three factors here, and we see that our least common denominator will be x times x minus 1. That's what I get when I multiply all three of those. Now, x minus 1 goes into x times x minus 1, x times. So 6 times x, 6x. We bring over our minus sign. X goes into x times x minus 1, x minus 1 times, leaving me with 6 times x minus 1. 1 goes into x times x minus 1, x times x minus 1 times, multiplied by 1, we have x times x minus 1. And again, I know that was just basically done in our heads. You can refer back to, again, previous examples that showed us actually how did we talk about doing x into x times x minus 1 and likewise. So we have our classic distributive property twice. We bring down our 6x. Negative 6 times x is negative 6x. Negative 6 times negative 1 is plus 6. Negative x times x will be negative x squared, and negative x times 1 will be positive x. And this is all over x times x minus 1 greater than or equal to 0. So as we look in our numerator, it looks like we get a couple of terms here that will help us cancel out, make it a little bit easier for us. The 6x minus 6x goes. And this would be negative x squared plus x plus 6 all over x times x minus 1 is actually greater than or equal to 0. So two more algebra steps here and we'll actually be finished with the problem to actually get our test points. Now, one thing that you'll notice is that we haven't looked at an example where our leading coefficient was actually negative, as it is in this case as a negative 1. So all we want to do to rectify, to fix that is actually factor out a negative 1 in the numerator. That way, this will cause all of our signs to change, and then I can factor a trinomial that has a positive leading coefficient. So if I factor out a negative 1, this says that now my negative x squared is simply positive now. Positive x is negative x, and this is minus 6 all over x times x minus 1 is greater than or equal to 0. As we factor this trinomial, two numbers that multiply together to get me 6, subtract to get me a negative 1 would be 3 and 2. And since I want my 1 here negative, this would be x minus 3 and x plus 2 all over x times x minus 1 greater than or equal to 0. Alright, and so now all of the algebra is over. And again, I'm going to forbear actually taking all of these terms and setting them equal to 0 to find out our test points. I think that it should be obvious now that these are easy one-step equations to solve that we would have to solve. And our test points will be very, very easy to come up with. So this lets us know that this factor here tells us that negative 2 would actually be a test point. This tells me that 0 would actually be a test point. This tells me, x minus 1 tells me that 1 is a test point. And x minus 3 tells me that 3 is a test point. And so just like the last example, we still have to consider -1 as we go through and partition the real line. So I write -1, x minus 3, x plus 2, x, and x minus 1. And so now the game is almost over. If I try to point to the left of -2, like -5, well, let's first of all, let's go ahead and make everything up here negative, because -1 is going to be negative. I don't care where you try, what points you try on the interval. So we don't have to always talk about that. So -5 minus 3 is negative. -5 plus 2 is negative. X is -5, so this is negative. -5 minus 1 is negative. If I try a point between -2 and 0, like -1, -1 minus 3 is negative. -1 plus 2 is positive. X is -1, so that's negative. -1 minus 1 is also negative. If I try a point in between 0 and 1, like a half, this will say a half minus 3 is negative. A half plus 2 is positive. 1/2 is positive. And 1/2 minus 1 is negative. In between 1 and 3, like 2. 2 minus 3 is still negative. 2 plus 2 is positive. 2 is positive. And 2 minus 1 is positive. If I try a point to the right of 3, like 5, 5 minus 3 is positive. 5 plus 2 is positive, positive, and positive. And again, we only need to consider the number of negative signs that we have here. We've got 5 negative signs, so this would mean that I'm negative here. I'm positive here because I have an even amount. A negative amount, an odd amount says that this is negative, positive, and negative. Now, so we want solutions this time that will produce positive solutions and those equal to 0. So I'm going to erase this time, and I know where my factors lie. So all those solutions that will produce, all those values of x that will produce a positive solution are found between -2 and 0 and 1 and 3. So I put -2 on the number line, 0, 1, and 3. And right now, because we're only considering those that give me greater than 0, my circles are open for the moment. And so I shade in between. And again, now the factors in the numerator of the rational expression will only be those factors that will allow us to have 0 in the numerator. So we need not consider x or x minus 1. And we see the only values of x that will produce 0 in the numerator will be positive 3 and -2. So that means that -2 is shaded in and positive 3 is shaded in, or closed circle. And that ends the problem.